All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue working on or learning slash working on. We're going to continue learning about ESP32 Rust things. We're gonna we're probably gonna look at the very first Arduino example and try to recreate that in Rust. And additionally, well, in addition to what I had yesterday, today I also have a potentiometer, which isn't exactly being shown very well on stream. Maybe I can like do something like this. There it is. That looks so weird. That looks so weird. But yeah, that's that's the that's the potentiometer, and I'm gonna be turning this off stream, off camera, uh, to show like value changes. I didn't do a very good job of soldering this potentiometer. I still have some stuff to work out in terms of soldering, and I mean, I still have to learn soldering. I guess that's a better way to put it, because it's not like I'm an expert in soldering. Give me a second. I haven't placed the breadboard properly. I think that's better. Okay, so um, yeah, I haven't soldered this very well, so it doesn't seem to be having the best connection. I don't know if it's an issue of the wire contact with the potentiometer legs or the wire contact with the breadboard itself, but just jiggling the wires seems to sometimes fix the issue. Give me a second. Yeah. Uh, you might notice the red LED all of a sudden started blinking much better. Um, I don't know. I mean, it is what it is. I need to solder another potentiometer later on once I've gotten a bit better at soldering, because there's still clearly a lot that I need to learn. Also, I was looking into this. I'm not going to be looking into it uh, during this stream, uh, but I've started looking into it off stream. And this is one of those interesting things. It's like it's a mixture of two things. There's two things I need to look into. One is the borrow checker thing that's happening. I kind of figured it out yesterday because it seems like into iter consumes the entire array, as in it moves the array. And so if you try to access it in the next loop, then you get an error. If you try to access the array in the next iteration of the loop, because we are within a loop, if you try to access this array within the next iteration, you'll get an error because the thing has been moved already. And so the solution, I believe, what we found yesterday was to just move the array from here, which is outside the loop, to inside the loop, and then that fixes the issue. Okay, now I'm gonna do something here for the sake of showing. Yeah, this should be okay. So I'm gonna hit run. We don't need the other two LEDs to be turned on. We just need the red LED to be turned on. And then I'm gonna turn the potentiometer. I have the potentiometer in series with another resistor, and then that's going to the LED. But I've chosen a pretty small resistor value. So hopefully, you know, that should work, and you should be able to see a difference. I'm just going to turn the potentiometer so you can, I don't know how well that's going to show up on stream. But let's see. As I turn it, you should see the LED becoming brighter and then dimming as well. Give me a second. I'm gonna reach for it now. Okay, there's also flickering because the contacts are not that great. I don't know how I'm gonna demonstrate this very well. Okay, now maybe. Okay, so you can see it became visibly brighter. Now I can turn it down, and now it's become dimmer as well. Ignore the flickering. I can't really do too much about that at this point. But yeah, yeah. Okay. Something we could look into additionally is how potentiometers work exactly, or rather, how we are meant to be using potentiometers. Because I'm currently using only two of the legs, not all three. And get used when all three actually get used in this what do you call it, in the Arduino example. I just remembered that. Yeah, all three of them do get used in the Arduino example. Give me a second, let me just open up my stream on my phone so I can see the chat. Okay, all right. Now, um because this is so unstable, I don't know how good our how good of a signal we're gonna get, how clean of a value, or how stable, I should say, of a value we're gonna get. I have no idea. We're gonna have to find out. So we can take a look at the Arduino example. Uh, Give me a second here. Let me just do this and open up the Arduino example. Okay, something just happened. Okay, all right, we are good. Okay, Arduino Uno examples. Built-in examples. Just a second here. I wish there was a simpler way to test this out, but like, I don't know. Oh, something I could do is maybe read from multiple analog pins, and then I can have like different resistor values set up. That's going to be too much of a setup though. It's definitely not going to be, it's not going to have that dynamic um, aspect to it where I can change where I can just, turn the resistor knob, turn the potentiometer knob and see the values changing. It's not going to have that effect. But yeah, yeah. Give me a second here. Okay. All right. Okay. So, yeah, I just remembered that I have not brought the browser back. Oh, also good news. I'm getting close to being done with uploading the entire VOD collection of February, which is last month. And after that, I'll start uploading March. So that's pretty awesome. That's good news. I'm slowly catching up. It's unfortunate that I'm not going to have the metadata for either of them. Maybe I could write a separate script. You know what? I could do that. Actually, I could write a separate script. Problem is, I'm gonna need video IDs for that, and I don't know if I need to use the YouTube API to even get the video IDs. And I feel like that would maybe complicate things a little bit. What I want to do is I want to start making clips whenever we move forward with the content pipeline development. I want to start making clips either from February's VODs or from March VODs, because already we are at almost the end of March, and I don't think I've missed a whole lot of days. I also don't think too many of the VODs have expired. I could be wrong about that. Maybe. I'm not sure. I'll have to check. But hopefully we have a good at least 15 plus VODs of this month. And so by the time the content pipeline is ready and I have a couple of VODs to pass through it, sorry, by the time the content pipeline is ready and I need a couple of VODs to pass through it, we are most likely going to have the entirety of March ready. Yeah, yeah. But okay, let's get into this example. So there's a couple of things to do here. We're going to read this. Okay. Yeah, we're going to read this, but we are not going to apply this to, we're not going to, how do I say this? We're going to read this entire example. We're going to read all the theory, but in terms of applying this, we're not going to follow the circuit diagram one to one. We might follow the schematic, but like we are not going to be, or even the schematic and circuit diagram, they're more or less the same here. We're not going to be following them one to one. Ooh, I just realized something. I was asking, well, I don't know if I asked this like out loud, but something that I was wondering was, could I get a potentiometer that doesn't require me to solder wires onto it? And I guess the answer for that is one of these potentiometers, because you have these, hold on, have they mentioned the name? No, they haven't mentioned the name. But you get these kinds of potentiometers where they essentially look like push button switches, but instead of a button, you have what looks like a flathead screwdriver screw, in which you can put a flathead screwdriver and just turn the knob, and that's how you control the resistance. Though I'd imagine not being able to keep the potentiometer away from the circuit, or rather having to put a screwdriver in the middle of a circuit, kind of poses its own challenges, its own risks. So I'll have to be careful with what I'm doing there. Though one advantage is I also have these really small breadboards, not super small, but like the the breadboard that you're looking at right now. It's like maybe one third the size of that breadboard. I want to say half the size, but I don't think it's even half the size. Could be half, but if we are going any smaller than half, then at the very least it would be like, or at most, I'm not sure which one to use there. Whatever. At the very least, it's going to be one third of the current breadboard size. So what I could do is I could put one of those push button, not push button, the variable resistors. I actually think I have one of them, because I had ordered those, what do you call it? I'd ordered those simple robotics kits. Let me show you exactly what I'm talking about. I hate that I have to do this every single time that I want to show something, every single time that I want to Google something. Now, what was that called? DIY tracking bot. It was a really simple, cheap thing. You don't even need a microcontroller for it. Um, what exactly was it called? Robot car kit. DIY smart tracking robot car kit. And this was great because this, like I said, it doesn't even need a microcontroller. They set up this circuit using discrete components and ICs. One of the ICs that was used was a comparator, and I don't remember which others were used, but other than that, they only had like capacitors, resistors, LEDs. I think I don't remember exactly what that was. Maybe it was a photo transistor or a photoresistor. I'm not sure. Um, but it was something that reacts to light signals, something that converts light into energy. It's basically they made up this. Hold on, let me bring the thing on. Robot car kit. Okay, so I'm just gonna show the browser now. Okay. Um, by the way, I've been thinking about something. I've been thinking about making a little control panel kind of thing to control my OBS, because I have multiple situations where I either have to go to BRB or I have to close one of these scenes, and I'm running OBS Studio in studio mode. So the way that it works is you have two screens. One is a preview and one is called program. Program is what you're currently on. Both of them are representations of your of what you will be streaming, but one of them is it's a sort of thing where you can work on the scenes, but that's not being streamed. The other one, which is called program, that is what's actually being streamed. So, for example, if I wanna hide the browser window, which is in the bottom left, I'll I currently have the that scene selected, and that scene is showing up in both the preview window and in the program window, or in the preview viewer and in the program viewer. But you guys are only seeing what's in the program viewer, not what's in the preview viewer. So if I now make the browser window invisible, or if I hide the browser window, that hasn't taken effect yet because that's still in the preview viewer. So I have to transition. I have to click the transition button so that OBS will transition from the current scene that we are in, the current, I shouldn't say scene because that means something in OBS. It's going to transition from the current version of the scene that we are in to the version that I have set up. So this allows you to do a bunch of things in the background. And then finally, once you have set everything up and you're ready to show the scene to your audience, you can then click transition. And this is super useful for doing a bunch of things. My setup is still not nearly as convoluted as a bunch of other people's setups. And I don't mean that in a bad way. I mean, like, a lot of people have very, very complex, very sophisticated things going on with their scene setup. There's various dynamic elements. There's various things that have like a wow factor, and that wow factor kind of, it dies out if people are able to see behind the scenes. So they need to try and hide the behind the scenes stuff. And that's where this preview window becomes very useful, because within this preview window slash viewer, you can make all of your changes to the scene. And then when you're ready to actually show that scene, you click transition, and then that scene moves over to the program viewer. Okay, now why was I talking about this? It's because I found myself in multiple situations where I had to hide the browser window, or maybe I have to refresh the RTMP source, or hide the RTMP source, and I don't want to have to do the whole clicking and transitioning thing each time. So what I was thinking is I'll create a Rust application that, and I'll add the OBS WebSockets library crate, the OBS WebSockets crate, to that Rust project, and that way I can send messages from there over to this OBS, because this OBS has a WebSocket running, a WebSocket server running that listens for connections over the network. So from any other machine across the network, I can send in messages. So I can create something as simple as a console app. Doesn't even have to be something that has TUI in it. Just a simple console app that runs a loop where it'll ask for what operation I want to take, and then I'll tell it that, okay, um, hide so and so scene, or whatever, however I want to do that, however I want to set up that entire program. I can set up a loop there, and just have it keep accepting input from me. And anytime I need to change, anytime I need to hide the browser, I can just type it in there, and then a bunch of steps will be taken here. The thing is, this would work if I'm able to see, if I'm not currently lagging. Like if I don't have like a latency, this would work great if I don't have latency. But I usually have latency. Anyways, I mean, it's something that'll first of all, I'll be able to do it in Rust, which is exciting. But also, it's something that'll introduce me to creating a control program for OBS WebSockets, because eventually I wanted to work on a sort of small keypad sort of thing that I can program to control various things in my OBS setup. Though it doesn't have to be in it doesn't have to be like a physical computer. It doesn't have to be a physical keypad sort of thing. It can be. That'll be very convenient. But it can also be a Ratatouille program. So I could just recreate the virtual stream deck that I had made in Python using Streamlit, I believe. Yeah, I can just recreate that in Ratatouille, and this time I feel like I'm going to do a much better job than what I did the last time. There's also the fact that Ratatouille is, like, fundamentally it operates differently than Streamlit. So the way to go about doing things is going to be very different. I'm also not going to be trying to make it like um, highly scalable, highly extensible, and all of that stuff. I tried to do all of that stuff with my virtual Stream Deck application, and it was great, but I never really used all of those extra features. I've had this problem for a while. It's not really a problem, but like kind of a problem. It sometimes makes me waste time because I try to make everything scalable and highly customizable. It's like, oh, okay, if I put in this extra bit of effort, then I'll be able to extend the functionality if I ever need to. the problem is I'm rarely ever in situations where I need to. So like I'm working on, and first of all, what I call, putting in a little bit of extra effort, it ends up being me putting a lot of extra effort and spending a lot of time working on those features. And in the end, I rarely, if ever, use those features. So it just becomes like a wasted effort. I really need to start building things with a specific purpose in mind and just stick to what exactly needs to be done and stop trying to make things extendable or extensible and scalable. Because due to this, my projects tend to take a lot longer because I'm trying to think about the future. And in thinking about the future, I, I don't work on what needs to be worked on right now. But anyways, okay, so I wanna work on an application that's gonna help me control various OBS things. Fortunately, there is already a library that handles the entire WebSockets communication, because there is a WebSockets protocol that OBS has set up. So whatever library you are using, whatever program you are using, it has to, in order to communicate with the OBS WebSockets server, it has to be following that protocol. There's a specific protocol, there's specific API, there's a specific way to communicate with the server. Your library slash program has to be doing all of that stuff in order to successfully communicate with the OBS WebSocket server. And lucky me, there are libraries in various languages, in fact. There are libraries that already implement this. It's kind of like if you want to be able to talk to the Twitch API, then you have to implement a library that knows how to talk to the Twitch API, because there's a certain protocol that they have set up in order to be able to have safe and performant communication, secure and performant communication, and also standardized communication. They've set up a certain way to do the communication. So if you're trying to communicate with the Twitch API, you have to respect that. Your program that's trying to do that has to respect that form of communication. Otherwise, you can't communicate. Similarly, in this case, you have to respect that kind of communication. You have to implement the protocol that they have built. Otherwise, you can't have the communication. So these libraries definitely help, because I don't have to reinvent the wheel, and I don't have to implement the thing from scratch. I can just pull the thing into my program, into my project, pull the crate into my project, and I'm good to go. Hopefully it handles the networking as well. I need to look into that part. I don't know if it handles the networking. Yeah, because the WebSockets message has to be sent over the network. Hopefully it handles that as well. But yeah, okay. Let's get started with this. Oh, yeah, I was talking about this thing, right? So in this kit, um, I believe I got this kit. This was the cheapest one of all of these. Um, and it also has the least amount of parts. Yeah, mine looks exactly like this. I probably even have those same wheels. This is not nearly the same quality as any of these. In fact, these seem to include modules and microcontrollers and stuff like that. Um, this would have been good for me to buy as well. The thing is, I want to buy one of these as well, minus the minus the microcontroller, because I don't need the microcontroller. I want to control. I want to get the modules. To be honest, I have the modules as well. I have motor drivers. I have DC motors to control those motor drivers as well. I have ultrasonic sensors for, I believe it's for distance calculation. I have, what else is there? There's probably a couple of other things that are required, and I have this. Anyways, okay. What else? words. Holy shit. What I was talking about is this kit. In this kit, this entire thing, there's no microcontrollers involved here. This is also one of those smart tracking cars, but this is built with discrete components and an IC. The IC is a comparator. And I believe these two things here, this is actually, I'm just realizing now, this window itself is really small. So you guys probably can't see jack shit, which is unfortunate, but it is what it is. Anyways, so the reason I was talking about this is because I think I do have one of those variable resistors, one of those potentiometers that I was talking about, the one in which you can like put a screwdriver and turn the thing. I think I do. I'm not sure. I'll have to check the kit. We can actually work with that as well at some point later on. Um, you know what? The thing is, the I mainly bought the kit not for the circuit that you're meant to set up. It's so that I could set up my own circuit in this. I bought this kit mainly for the motors and the frame because I needed a frame and wheels and like axles and stuff. Basically something that I could set up a circuit on. I needed the mechanical components. That's why I bought the kit. I wasn't even planning on setting up the circuit that you're supposed to set up. I'm planning on using those components separately. That's why, because because I got the comparator IC with this, so that became like a bonus for me. That, oh yeah, this is great. I can learn about comparators in this way. Okay, so going back to this, we are gonna be doing this example. We are gonna have to convert this circuit diagram to something ESP32 compatible. And we are also going to have to convert the code to something ESP32 compatible. So I'm going to have to copy paste this code into Gemini so Gemini can give me the exact thing. I feel like it would be better if we could try and understand what the code is doing, because I know how to read the code. I know how to read C, C++ code, maybe not highly advanced C, C++, but this is like, dude, Arduino C, C++ is usually pretty basic C, C++. Unless you start going into like pointers and stuff like that, then yeah, maybe the logic gets a little bit complicated and it might be a little harder for me to understand. But very basic C, C++, I can very easily understand because the syntax is almost identical to C sharp. This is taking some time to load. Let me refresh this page. Dude, my CPU's fans are going crazy. Let me see if there's something I can do to get them to relax for a little bit. It's probably going to freeze something here. Okay, so this is gonna let it relax for a little bit. I think the matrix rain is frozen on stream right now. Yes, it is. We're gonna leave it frozen while the thing relaxes for a little bit. I'm gonna switch to the BRB screen because I need to take a quick toilet break, and I'll come back and then we'll start doing this. So give me a second. Actually, a couple of minutes. Okay, I'm back, and let's get the feed back up as well. My CPU has only cooled down like a couple of degrees. So I mean that did reduce the sound a bit. Yeah, that did reduce the CPU fan sound a bit. Um, Hopefully it lasts for the next like maybe hour, because I do have like a good hour more that I can stream for. And yeah, dude, let's hope that in the next hour we are able to make a good bit of progress and learn something. Okay, so I refreshed this page. I need to scroll down and see what's going on with the code, because this code doesn't seem to be loading. Do they have like a GitHub or something where I can look at these? Because it seems to be dynamically loading something, and that's kind of fucking up on my end, because of which it's not like the code itself is just not loading. GitHub Arduino examples. Arduino IDE bundled examples. Yes, okay, they have the entire repo there. So here's what we can do. Okay, let me open up the examples. Okay, basics. I love that. I love that they have organized this entire thing, and this is from the official Arduino account as well on GitHub. Shout out to shout out to Arduino. Here's what I'm gonna do. Okay, I am gonna hide the oh god, which scene am I on? This one. I am gonna hide. Wait, are we good in terms of lag? Hold on. I don't think we are. Hold on. I need to. Okay, 1, 2, 3, 4, 5. That's a couple more seconds than what I want. Let's see if we can fix that. Okay, let's try that again. 1, 2, 3, 4, 5. Okay, that's better. That's like a 1 to 2 second latency. Okay, so I was gonna close the browser window, or hide the browser window. We're gonna open up the GitHub, so Arduino examples. I guess I didn't type Arduino, I typed Ardui. Fortunately, Google got the thing right. So I'm gonna open this up, let that load, and then, oh, I can probably open it up with that file explorer kind of thing that they have. Hold on, let me open up one of their files. Let's open up, okay, yeah, let's just open up examples. And then once I'm in there, I should be able to open up that file. Oh yeah, there it is. Okay, cool. So I'm gonna show the browser window. Um, okay, and okay, great. So this is where we are at right now. We are currently in basics. Under basics, we are in analog. Wait, they have the text as well? What's under text? Maybe we don't need to look at the we need to look at the website. Okay, I was about to say maybe maybe we don't need to look at the website, but no, we need to look at the website. Where's the code? It's in INO. Is INO their extension for Sketch, as in their Arduino sketches? I think that might be the reason. So we're not looking for .c or .cpp files. We are looking for .ino files. C would be C, CPP would be C++. I'm not sure what INO is. Hold on. Let me ask Gemini. In Arduino, when looking at the example sketches, I was expecting C or CPP files, but what I'm seeing is INO files with C/C++ code in them. What is INO? I accidentally misspelled INO there. Okay. It's a bit jarring the first time you see it. Like, oh, okay, fine. Yeah, analogies. Great. The .ino extension stands for Arduino. Oh, Eno. Okay, now I get it. Somehow that didn't occur to me. Because I read INO and my mind went to INI. That was a different, those are different types of files. But okay, and it is essentially a C++ source file with a few quality of life tweaks designed to make coding easier for beginners. Okay, I don't need to read the entire thing. That is satisfactory information for me. Now, what we can do is, so we have the code here, we have the text here. Additionally, because this exercise is focusing on a potentiometer, and we have a somewhat dodgy potentiometer that we can use. I don't think the potentiometer itself is bad. It's the soldering that I've done on it, and possibly the contact between the single core wire and the breadboard, because sometimes there are some issues there as well. Like sometimes the connection isn't that great. Um, I forgot what I was talking about. Where was I going with this? But yeah, anyways, that's we're gonna be learning about potentiometers in this example. Right, I guess let's get started. So this example shows you how to read. Actually, wait, I need to open up a conversation with Gemini. And okay, I'm currently going through the Arduino examples to learn to learn. However, I'm applying them to ESP32 circuits, not maybe I shouldn't mention that. Actually, no, I should mention that here. I should open up a separate conversation as well. That okay, I'm learning about electronics using an ESP32. Teach me about potentiometers. Okay, so that's one conversation. Another one is this one. Okay, so here I can say I'm currently going through. Yeah, I don't need to mention all the extra detail. I'm currently going through the Arduino examples and applying them to ESP32. Trying to apply them to ESP32 instead of Arduino. Help me understand how to approach this, how to approach the following code Ooh, I should also mention, and trying to apply them to ESP32 Rust using no underscore std Rust instead of Arduino C/C++. Help me understand how to approach the following code in using ESP no std Rust. Let me copy. I need to be able to copy this. Okay, did I open that up? I did. Yes, I did. Okay. So we have the example here. Basics, analog. I wanna try and challenge myself a little bit in terms of like I don't wanna just vibe code the entire thing. I wanna try and challenge myself a little bit um, to explore the ESP32 HAL API. So maybe what we could do is like, okay, here we have um, here we can understand this code, and then I can try and ask Gemini how to do the specific things that the code is doing, that I think the code is doing. So here we are doing serial.begin, which I'm taking it to mean that some sort of serial communication is being set up. Oh yeah, it does say initialize serial communication at 9600 bits per second. I'm assuming that means a 9600 baud rate. ESP32 has its own baud rate though. No, actually, I think I can set a baud rate by myself. Okay, okay. So what I could do is let me open up yet another conversation with Gemini and ask or mention I'm doing no STD Rust coding for the ESP32. How do I set up serial uh, communication to do analog reads? Another thing I should look into is um, so okay, serial communication has an analog read. Wait, no, it just says analog read. It's not serial dot analog read. Okay, I read that wrong. Okay, because I was about to ask that if serial has an analog read, is there a digital read as well? Here, serial is not what has the analog read. Analog read is its own thing. And yes, there is a digital read and digital write, because digital write is how you write values to the pin. And here on the ESP32 side, specifically on the Rust side, it's a very different way of doing it. Okay, setting up analog reads with serial output in a no STD environment for the ESP32 is a bit of a leap from the standard Arduino serial.println and analog read workflow. Okay, since you don't have the standard library, you'll be interfacing more directly with the hardware abstraction layer, or HAL. In the Rust ecosystem, we typically use the ESP HAL crate. Okay, I'm glad that it's explaining all of these things. So this way I'll be able to like come up with solutions in the future, or maybe at the very least ask very specific questions to get my answers. Okay, the core components. To make this work, you need two main drivers configured: UART to send data back to your computer, and ADC, which is analog to digital converter, to read the voltage levels from your pins. Implementation strategy. Here's the general flow for your main.rs. This assumes you are using ESP-HAL. I am. Okay. Initialize peripherals. First, you'll take ownership of the device peripherals and set up the system clocks. This is where clocks come in. Okay, this is where clocks come in. All right, configure UART. You need to pick the pins for TX-RX, usually GPIO 1 and GPIO 3 for the default USB to serial bridge, and initialize the UART driver with a specific baud rate. Okay, configuring ADC. Damn, this is, holy shit, this is really involved. This is, yo, there's, hold on. Do they have, um, do they have an example here? Okay, button interrupt, hello world, DMA. I don't think serial, I don't think there's a serial example here. Sorry, zoned out. Okay, so there is a good bit of information being given here. It cannot be this. Holy shit, this is so complicated. No, wait, no. I feel like, no, wait. ESP32, no STD, serial, um, analog, read, example. ESP32 ADC, read analog values. Okay. Arduino ESP32 analog read. This is from Espressif. Let's open that up. This is C++. That's not what I'm looking for. Um, there's serial.begin. Okay, what all is this example asking me to do? Because let me show you the entire code that's being given here. Where do I paste this? This is not going to be as simple as maybe in lib. Actually, under bin, can I not have multiple things under bin? I don't know. Let me make a main o2.rs. Actually, let's make it bin slash main o2.rs. Save it. That's insane. Okay, I was not trying to do that. So we need to go and clean that up. Oh, actually, we don't need to clean it up. Hold on. We can just, no, not that. We can cut this and paste this here. Oh God, the fans. Okay, great. Right. What was I trying to do? Okay. Are we good with IntelliSense here? Yes, we are fine. So what it's trying to, is this going to paste? Yeah. So this is the code that Gemini has suggested for doing serial communication. This is a lot of setup. I mean, these are the using statements. So like, I'm not complaining about that. These here are all they're using statements. But then here, okay, so we have to, this is older code. I think this is older code. I think Gemini has older code. I think for this specific thing, I might, words, holy shit. I think for this specific thing, I might need to do a bit of Googling myself. I also should have mentioned Rust. No STD, Rust. analog Rust serial analog read example. Okay, so we have ESP HAL, and under ESP HAL, we could, okay, um, what is this? This is no STD training. Let's see. Okay, there's documentation. HIL guide, developer guidelines, chip bring up. Uh, is there like a website where I can look at this? The Rust on ESP book. All right, let's take a look at that. Okay, no STD on. All right, this doesn't seem to have too much going on here in terms of examples. If I could get like a reference of some sort, that would help. Let's look at the embedded Rust book and see if anything pops up there. Because I feel like what Gemini is going to give me is not going to be accurate. It's not going to be new. It's going to be giving me a bunch of older information. And I need to... Wait, how accurate is this information? Embedded Rust book. Okay, okay. Huh. Okay. ESP HAL. Let's just look at ESP HAL. Under ESP HAL, we have, okay, for help getting started with this HAL, go to the Rust on ESP book. Okay, great. We are in that book. Hardware overview, tool chains, application development. Okay, let's look at application development. Let's see if some useful information shows up there. Application startup and bootloader, configuration, logging, allocating memory, async options, testing over-the-air updates. I'm not sure which of these I need to be. There's also the fact that I'm looking for no STD specifically, but then no STD doesn't seem to... Oh, ESP HAL is for no STD. Okay, all right, okay. Um, that's something good to keep in mind. Let's... okay, ancillary crates overview, ESP HAL documentation. Let's see where this leads. Okay, now we have proper documentation. Okay, so let's open this. God, the fans are getting loud again. Give me a second. I'm gonna let the fans calm down while I do the searching. So the matrix rain is gonna freeze. Actually, everything else is gonna freeze as well. Okay, this documentation is built for the ESP32. Please ensure you are reading the correct documentation for your target device. Peripheral drivers, the ESP have... Yo, okay, there's... Right, I think this is the information I'm looking for. Yeah, I think this is the information I'm looking for. That being said, how can I find serial? Is there a serial thing? Is there a UART thing? Okay, there's UART. There isn't something saying serial specifically, but there's UART. So we're gonna look into that. Um, there's SPI, which is serial peripheral interface, but that's its own thing. I'm looking for a simple. Oh, I could try searching for a function named analog read and see where that takes me. Analog peripherals. So there's an analog peripherals module. This is available in unstable. All right. Okay. There's ADC and DAC. Okay. Okay. So we have an example here. We have an example here. Read an analog signal from a pin. Let me copy this code and paste it here. Okay. What are we looking at? So we have source. Don't want to make the same mistake again. Bin, and then let's do main03.rs and paste. This is a code that that's given in the example. This has to go within a, wait, is there a code actions thing that's going to let me, no, okay. Okay, let's just do fn main this, and then come down here, do this and save. I think even the LSP is probably not working, because otherwise we would be getting code formatting thing, the code formatting stuff. To be fair, I think it's not working for this one either, for main O2. Okay, anyways, whatever. Expected item found so and so. Oh, I just realized you guys can't see this. This is what I'm doing. I just remembered that I had yeah. So this is what I'm doing. But the IntelliSense doesn't seem to be working here. I've forgotten how you can have multiple main things. Let me. Hey, remind me again about that whole src/bin folder structure in Rust projects and how it works. In Rust, the SRC directory is the heart of the project, but the way it handles binaries versus libraries can be a bit, can be a little bit, can be a little confusing at first. Oh, is bin supposed to have, like extra directories in it? So like then we can launch whatever specific project we want? I think so. I think that's how it's supposed to work. So you can either have a main, actually no, through this, like through bin. Wait, no. Okay, let me continue reading this. But the way it handles binaries versus libraries can be a little confusing at first. Cargo follows a convention over configuration approach, meaning it looks for files in specific places to decide what to build. Okay, the default main.rs, by default, every cargo project expects a single primary entry point, which is src/main. The behavior when you run cargo run or cargo build, Rust compiles this file into an executable named after your package. All right. Then the src/bin directory. If your project needs multiple executables, for example, a server and a CLI tool in the same repo, you use the bin folder. Okay. How it works, the path is src/bin, and every Rust file placed inside src/bin is treated as a separate executable. Complex bins. If a specific binary needs its own submodules, you can create a folder inside bin, such as src/bin/tool/main.rs. Sorry, zoned out. How to run them. Cargo run bin file name without extension. Okay. All right. So that's how it's supposed to work. I am not sure why we are getting this error here. This should be working. Okay. Oh, there's a bunch of this stuff. Okay, let's yank this and open this and paste. All right. Cannot find attribute entry in the scope. Unresolved imports. Huh. Okay, hold on. Allows us to use WriteLine with UART. Okay. Okay. So there's a different way to I can actually open this up in on this browser to show you guys what documentation I'm currently looking at. Actually, I should search for the exact thing and then open it up. So docs.espressif.com/projects/russ/espHal/1.0.0. Okay, all right. Give me a second here. Okay. Um, all right, that's opened up. Projects, Rust, no STD training. I'm supposed to be going for ESP specifically. The interesting thing is the links that are provided here are kind of all over the place. So I need to try and find. Okay, ESP has examples. That might have the. I hate this thing. This thing just doesn't disappear. Let me try refreshing. Hold on. Okay, are we good now? I think we're good now. Okay. Rust. So we're going to open this up. And then here, I came down here and looked for ESP HAL. And then I selected my specific chip. This is how I got to it. This is crazy. I feel like I should make a repo of examples and a whole bunch of information for people to be able to get started with this. So this is what I'm currently looking at. In here, what I did is, wait, they have a Blinky thing set up. Okay, that's our basic example. They did also include CPU clock here. Oh, actually, wait. I'm also realizing that they are not using delay here. They are using, um, hold on. Because they initialize the clock for something. They initialize the clock for something. I need to look into what duration is using and what instant is using. Because this is a different way of doing doing pretty much what we've been doing so far. We can try applying this actually. Hold up. Let's move over to this and over here. What is this? So we have config, ESP config default with CPU clock. With CPU clock, CPU clock. I don't think I have. Wait, CPU clock max. Yeah, I don't think I had that imported here. I think that just got imported. And then duration and instant were import. No, I think CPU clock was imported. It was part of the other code that I was looking at. This code is like all over the place now. Okay, and then we initialize the peripherals and pass config. In here, we don't have to make any changes. But then down here, we can change what exactly. Um, okay, so we do LED O2 dot toggle and then let delay start. Wait, what is this? Delay underscore start equals instant now. What does that mean? Returns the current instant. The counter won't measure time in sleep mode. The timer has a 1 microsecond resolution and will wrap after 36,558 years. That's insane. That's insane. Okay. Um, to be fair, I think they're just trying to be factual and give us the information. It was just kind of funny seeing that being mentioned. Okay, while... Wait, that's the line? While delay is so-and-so, do nothing. Okay, so I probably won't need my container. No, sorry, my counter. So I can do this. Oh, I do need my counter. Um, actually, no, I can just crash the program. Okay, duration from milliseconds, 500, then this. So this should make our, oh, could not determine which binary. Yeah, I have multiple here. That's my bad. Let's, no bin target named main. Wait, how are we supposed to run this? Ah, okay. Give me a second. So we have main. Did I spell main wrong? No, I spelled it right. Cargo run bin so and so. What's the error? No bin target named main in default run packages. Available binaries are ESP32 proj. Oh, should I name main to something else? maybe maybe I should name main to something else. Let's because maybe main itself is reserved for something. Let me ask Gemini. I have set up um, a bin folder with main, main O2, and main O3. Running cargo run bin main doesn't seem to work. The issue usually stems from a naming conflict or a misunderstanding of how cargo prioritizes the SRC um, the SRC root versus the SRC bin folder. In Rust, if you have a file named src/main, that is automatically the default binary. If you put a file named main.rs in src/bin, cargo can get confused because it sees two different things trying to claim the name of your package. Check for name conflicts. Do I have a second main? No, I don't. Okay. There's no... Okay, correct the naming convention. To keep things clean, avoid naming files main inside the bin folder. Rename them to reflect what they actually do. You know what? Okay, let's do that. I'll need to close this and then come here, rename this to main O1. Okay, now let's open this, and now we should be able to run this. Yes, great, awesome. Okay, it works. Awesome, great. Our green LED is blinking. Just a second. Oh, we're on quite a delay on the stream. Well, I was like my version of my version? No, my on my phone it was kind of delayed because I have the stream running on my phone as well, so I can look at the chat. But yeah, okay, so this works. I guess this is a different way of doing... I guess this is a different way of doing the delay thing. But yeah, let's continue here. Okay, the HAL implements both blocking and async APIs for all applicable peripherals. Where applicable, drivers, I guess they meant, drivers implement the embedded HAL and embedded HAL async crates. Drivers that don't currently have a stable API are marked as unstable in the documentation. Peripheral singletons. Each peripheral driver needs a peripheral singleton that tells the driver which hardware block to use. The peripheral singletons are created by the HAL initialization and are returned from init as fields of the peripheral struct. Peripheral struct. Would output count as that? I'm not sure. Okay, so this is interesting. Output is specifically for GPIO pins. I don't think this is meant to be for analog related stuff. Yeah. Um, okay, if you want to use the peripheral in multiple places, for example, you want to drop the driver for some period of time to minimize power consumption, you can reborrow the peripheral singleton. Okay, this is interesting. So we are not doing to create peripherals. Oh, we are doing that. Wait, we are doing that. This is for the pin. I was looking at the wrong thing this entire time. So this is our peripherals thing. Init returns peripherals. My bad. I was confused. Initialize the system. This function sets up the CPU clock and watchdog, then returns the peripherals and clocks. Okay, this is returning the peripherals and clocks. What do we have access to under peripherals? We have a whole bunch of GPIO pins, and we have these as well. Now, how are we reading? Do we have ADC? Give me a second. I'm just okay. There's DAC. Oh, there's ADC. There's ADC 1, ADC 2. I'm assuming this is what we need to use. We have a plethora of examples in the. Oh, you know what? Yeah, I haven't looked at the ESP HAL, have I? I don't think I have. Um, Wait, we could use this. We could use these examples, dude. I didn't think of that. I was looking for the no STD training thing. CDC ACM serial port example using polling in a busy loop. Okay, we need to find an example here that what's under extras? Bench server, so and so, so and so. No, these are much more advanced things. So under peripheral, our thing is specifically um, peripheral related. I am curious about the async examples. This is using Embassy. Okay, okay. So we'll get to this later on. This is why I was curious because I was wondering if it uses Embassy or um, if it's doing its own async runtime kind of thing. Okay, this is our basic example. Okay, flash read write. Let's take a look at that. I need to see where in here I would have, wait, would search work? No, their search only works well if you are signed in. Um, I am actually signed in one place. Hold on. So we can go to, what is this? GitHub, ESPRS, ESPHAL, tree, main. This is great because there's so much to explore here. It's just a little frustrating having to go dig for stuff, but it's amazing that there's an insane amount of stuff to explore. Um, just a second here. Okay. So, in here, I need to look at peripheral because I'm assuming that's specifically where we're going to find. Okay, what's under touch? Touch gives us capacitive touch, right? Is that going to include anything serial related? Okay, great. This is touch. This example shows how to configure a pin as a touchpad. Awesome. Great. So they have some comments, or at the very least they have comments at the beginning of the thing, which is great. I don't know what a bunch of these mean to what would HMAC be? Okay, hold on. I'm gonna open up Copilot in that specific folder. Could you scan this folder and tell me which examples would teach me about doing serial analog read and write. I'm glad that GitHub gives us at least a free, certain number of free, I'm not sure what unit to use there, free tokens, free requests per day. They have some sort of thing for like free, but they give like a good amount. It is still analyzing the directory. And yeah, the good news is I don't need to get it to. Oh, best match for serial I/O is USB serial. This demonstrates serial communication via USB CDC ACM. The example shows reading and writing from a serial port using serial.read, writing data back using serial.write, and polling based I/O in a loop. Oh, also echo functionality with data transformation. For analog reading, touch, while this is technically for capacitive touch sensing, not general ADC, it demonstrates analog value reading. That's a good point. Actually, that's a good point. Reading analog measurements from touchpads using touch0.read, setting thresholds and interrupt handlers, polling analog values at intervals. The examples peripheral folder doesn't appear to have a dedicated general purpose ADC example in the current structure. For basic analog reads, you might want to check the main examples directory or look for dedicated ADC peripheral examples. Directory structure, so and so, so and so, so and so. Okay, would you mind going through the examples directory and telling me if there are any examples that would teach me about analog read and write? The search results aren't showing dedicated ADC slash DAC examples. Let me search more specifically based on comprehensive scan. I have bad news and good news. The bad news is there are no dedicated analog read slash write examples in the main examples directory structure. The subdirectories I found are async, BLE, ESP now, and so okay, it's just listing out this entire. Hold on, here it's listing out this entire list of directories under. Actually, wait, it's listing out this entire list of directories: async, BLE, ESP now, hello world, so and so, so and so, so and so. Okay, the good news, ADC is available and well documented. While there is no standalone example in the main examples folder, I found test/reference code. There are working ADC examples in QA test/source/bin. It shows async ADC reading with both blocking and async patterns. Basic pattern, ESP HAL, analog, ADC, okay, pin value, so and so. Okay, let me just copy this over so you guys can see it as well. I'm gonna save this, and we need to open this and this, and then main04.rs, and then paste. This is the very simple example that has been given. We need to wrap this into main. Oh, we don't have a bunch of that other stuff. We need all the wrapper code, all the boilerplate code as well. There's okay, I guess we'll copy this entire thing, yank, and we'll drop it down here. Actually, okay, we can drop it here. Oh, yeah, we can put this here. Okay, that's fine. Panic handler, bootloader. Okay, okay, okay. We can delete a bunch of these things. Yeah, actually, we can delete a bunch of these things. Get rid of this. Get rid of... You know what? Let's keep one. Let's say let LED02 equals output. That's not working. Why is that not working? We do have output here. Oh, this is why. Let's drop this in here. Config. Okay, why is IntelliSense not working? Wait, let's close this and try to reopen. Okay, there it is. New, we pass in peripherals dot... Oh, it's supposed to be GPIO. What was the... I forgot the pin. Hold on, I need to... What was the middle one? I think 5. I think it was 5. Level low, and then output config. I don't remember what that was supposed to be. Was it default? Yeah, I don't remember. Now, what's NB supposed to be here? NB block. NB block. Regarding analog, right, I didn't find any so-and-so recommendation. Consider checking so-and-so. Okay, in here we... Okay, so we have certain things to look into, right? So we are looking for the ADC. Now, under ADC, we are looking for, okay, the ADC is integrated on the chip and is capable of measuring. This is, dude, it's crazy how different this is from doing it in, let's say, MicroPython. I'm pretty sure it would be different. Actually, okay, I can't say that for sure. I was about to say that I'm pretty sure the C++ version for ESP32 would have been different as well, but I can't say that for sure. Okay, the ADC is integrated on the chip and is capable of measuring analog signals from specific analog I/O pins. One or more ADC units are available depending on the device being used. I love that there's documentation here because this is helping immensely. And it's going to help in like further things as well. Right, so this is an example that they have given. Um, the interesting thing is NB is not being defined anywhere here. What is NB supposed to be? I need to find out what NB is. NB block. Let me try typing that out. Maybe IntelliSense is gonna find it somewhere. There's nothing. Nope. NB. NB block. Actually, let me try asking. Hey, I can't seem to find NB block. Good catch. NB block. The NB block macro is from the NB crate, which needs to be in your cargo.toml dependencies. It's a non-blocking pattern helper crate. NB. Okay, the NB block macro converts non-blocking operations that return NB result into blocking calls by polling until the result is available. Alternative approaches without NB block, if you want to avoid the dependency, you can poll manually. You know what? I'll do that. I'll do that for the sake of actually no. It said if you want to avoid the dependency. Or if you're using async slash await in Embassy, then do so and so. Okay, hold on. To be clear, this code and even the NB, no, wait, to be clear, the NB related code will compile fine for the ESP32. Good question. Let me search for actual non-blocking ADC examples to see what's tested. Yes, NB block code will compile fine for the ESP32. Here's why. Hold on. At what point do they mention the NB crate in... Okay, here's why. The ESP32 uses extensor architecture. The ESP HAL has an extensor.rs implementation that includes the read one-shot method returning so-and-so. Okay, all implement read one shot, returning so and so will work seamlessly. You know what? I think I'll stick with just that block. I don't think I want to overcomplicate things for myself. I think I'll stick with that block thing. I need to explore NB and understand what's going on there before I proceed with this. I feel like I am gonna need to do a thing where I learn to put a pause on this, especially if we're gonna be doing more and more ESP32 streams. I'm gonna need to note down exactly where we stop and what specific things I need to look into. Actually, okay, for that purpose, temporarily I can open up the mind map, ESP32 stream notes, post stream notes, post stream, post stream notes. Look up NB and NB block, read ESP underscore HAL, ADC docs, understand what all exactly ESP HAL is implementing. Actually, no, understand ESP HAL. Let's just say that. Understand exactly what ESP HAL is and does. Because so far, all I know is that ESP HAL it contains the ESP version of the ESP version of the embedded HAL um, interface, I guess I should say. Yeah, it contains the ESP implementation for the embedded HAL interface and the various things that are provided with that interface. But like, for example, I I I didn't know that ESP HAL was specifically for no STD. Um, so that's good to know. Something that's specifically for no STD is it'll be useful for whatever I'm doing. But yeah, okay. You know what? Uh, okay, give me a second here. Uh, okay, yeah. You know what? That's gonna be it for today's stream. I'm not gonna be raiding anyone. I'm just gonna end the stream here. And I have a bunch of these things to do. I have a bit of soldering practice to do later on as well. Yeah. Okay, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.